we're trying to improve. If you look at the latest estimates, say that came out of the last IPCC report, you talk about 1 to 3 feet. But the problem is even just the last year, there's been a lot of new results that came out. Destabilization of part of the Antarctic ice sheet, significant amounts of melting in Greenland, and other projections that say, hey, could we have a lot higher sea level rates than that? Could we have 5 feet, 10 feet in the next 100 years?
Sounds quite scary, and I think the other thing that people will find quite frightening is you're seeming to say that these rising sea lines are already happening. There's not much we can do to stop it going up.
No, what's fascinating is that occasionally people will say, well, is it really happening? Cities like Miami are already routinely experiencing flooding, right? Storm damage has increased in the United States because sea levels are higher and the storm run-up's higher. Kennedy Space Center, NASA's own spaceport, they've actually even gone as far as to make a map of areas they know they're going to lose as they experience increased erosion. So the planet's not just changing, it's changed. But I think what we need to do is we collect the data to let its society make the best informed decisions it can. And for infrastructure planning, for big things along coastal areas, we need to do a better job with those 100-year projections.
It clearly is worrying the number of people who could be impacted by this, literally billions of people living relatively close to the coast. What should be done? Do these people need to move away from the coast? Would you buy a house on the coast? Do we need to look at where we're building?
So it's a little bit more complicated than that, right? Like the people that we think are immediately going to be affected by sea level rise is more like 150 million. They're affected by that 3 feet number. It's also kind of a slow thing. What happens is, even if it's rapid, it still is enough that people don't have to flee from the beaches kind of thing. But there are places those people are going to have to go. And so we have to accept the fact that there will be migrations away from those zones. But what we also have to accept is things like there'll be more saltwater intrusion into freshwater aquifers. We need to accept that a lot of our infrastructure and, people who live away from the coasts, this is an issue for them because most of the world's big economic drivers, those are cities that are in coastal areas because that's where the ports are. So this is an important issue across the board.
And how much of it is down to human activity?
Oh, look, no one questions those kinds of things. The planet is warming up, right? As the planet warms, that causes the ocean to thermally expand, and it causes us to lose more ice into the oceans. That's not really where the debate is. And the thing that I think we really need to focus on is this, is kind of what do we do? Because it's happening right now. A certain amount of it is locked in, but we certainly have the chance to help change things for the kind of next generation, our children's children and things. We can have a big impact on their world.
Dr. Thomas Wagner,
more than 90% of our planet's freshwater ice is bound in the massive ice sheets and glaciers of the Antarctic and Greenland. As temperatures around the world slowly climb, meltwaters from these vast stores of ice add to rising sea levels. All by itself, Greenland could bump sea levels by 7 meters or 23 feet if its ice melted completely. And it's melting. In August 2014, Eric Renaud, a glaciologist working at the University of California, Irvine and NASA's Jet Propulsion Laboratory, led a team in mapping ice cliffs at the front edges of 3 outlet glaciers in Greenland. The researchers found cavities that undercut the base of these leading edges that can destabilize the ice front and enhance iceberg calving, the process where parts of the glacier break off and float away. In Greenland, we have melt rates of a few meters a day in the summer months, says Renaud. What's causing this big thaw? Renaud's team found that Greenland's glaciers flowing into the ocean are grounded deeper below sea level than previously measured. This means that the warm ocean currents at depth can sweep across the glacier faces and erode them. In polar regions, the upper layers of ocean water are cold and fresh, he explains. Cold water is less effective at melting ice. The real ocean heat is at a depth of 350 to 400 meters and below. This warm, salty water is of subtropical origin and melts the ice much more rapidly. Renaud's research team is providing critical information needed to document this effect and accurately predict where and how fast glaciers will give way. The team gathered and analyzed around-the-clock measurements of the depth, salinity, and temperature of channel waters, and their intersection with the coastal edge of Greenland's ice sheet. They found that some of the glaciers balance on giant earthen sills that are protecting them for now. But other glaciers are being severely undercut out of sight beneath the surface, meaning they could collapse and melt much sooner. It's not easy gathering such data. On top of the rough waters, wind, rain, and cold weather, there's the ice itself. We came to study glaciers that discharge into the fjord, and the fjords are full of ice. In some places, it can be so full of ice that the boat can't even push through. But ice holds a peculiar fascination for Renaud. I've always been interested in polar regions. My friends wanted to cruise in the Caribbean, but I'd rather cruise here in these waters. I don't know why, I just like them. Maybe this photo provides a clue. What's next? OMG, answers Renaud, and he's not using chat speak.